Hello everyone and welcome to today's video on graphing straight lines. Yes, I know, random. You're sitting there going, hold on, I swear this was a Methods 1 and 2 course. And I'm going to say, yes, it was. Hello and welcome. I'm Darren, MaffsGuru. Very pleased to meet you. Now, please don't stop watching. Graphing straight lines, yes, is the topic for Methods 1 and 2. Now, again, if you're sitting there going, what on earth is Methods 1 and 2? Well, it's a course over here in Australia, but you cannot tell me that graphing straight lines is not universal. Well, you can, and you can leave a comment below and say, actually, you know, Darren, we don't do graphing straight lines here in whatever country you're in, but I should think you will. It's very important. Now, if you are new to my channel, can you do the massive favour, please, of clicking the red arrow over there that's pointing and says something along the lines of subscribe, show me some support. As I say, I am a very small person trying to do a very big job here, and I'm doing this all on my own for you guys, but I'm also sitting in a room talking to myself. It's very weird. So if you can subscribe, great. If you can let your friends know to subscribe as well, even greater. But let's get on with this graphing straight lines. Now, by the end of this video, I would very much like to, I don't know where it is, up there somewhere, make sure that you understand how to sketch graphs from intercept form, gradient intercept form, and obviously know how to do this on your CAS. Now, a CAS calculator is a wonderful, wonderful thing, but there are also times when you are not allowed to use it if you're over here in Australia. So in previous lessons, and again, there is a link above to a previous lesson, we looked at the general idea that a straight line can be expressed in all sorts of different ways. Gradient intercept form, we can go on and have point gradient form to help us substitute in. But generally speaking, this here is the general form of an equation. Now, to me, as I said in the previous video, if it's equal to 0, don't panic. It doesn't suddenly mean you've got to solve it like a quadratic. Maths is just going to try and trick you. Barry, hashtag no more Barry, is going to throw you. So we can generally rearrange that equation. So if I had something like 3x plus 2y minus 6 is equal to 0, well, that's the general form of that equation, but we can rearrange that to have 3x. Oh, we have 3x plus, I don't know what's going on with my tablet here, 3x plus 2y is equal to 6, so I've just added 6 to both sides. I can rearrange that to have 2y is equal to minus 3x plus 6. We're getting closer, and I can then divide everything by 2 to have minus 3 on 2x. Plus 3. And there are 3 different forms that we would like to use. So this one here is great for simultaneous equations. That's called the intercept form. And this here is the gradient intercept form. Very exciting. So a couple of examples of gradient intercept form. Just there, y equals 3x plus 4. Because when we look at it, we can see the gradient and the intercept straight away. Because we've known from previous years that that's y equals mx plus c. And then we have this intercept form, which I have to say I love. It's used in simultaneous equations, and it helps us find the values of y-axis intercepts and x-axis intercepts really, really easily. So let's do some sketches from each of these forms. Now, a sketch in mathematics has to be relatively accurate. Yes, it's not like grabbing a pen and going, oh, because that's a bit weird. What it does mean is it's got to have sort of endpoints on if the domain is limited, and you're going, what are you talking about? Chill, we're getting there. It's got to have straight lines where it has straight lines. It's got to go through the points that it needs to. Now, I'm going to find that really, really hard because I'm using, yes, electricity. This isn't a real pen. I wish it was because it's freaking awesome. But you, when you draw these things, can actually do it much, much simpler. So sketch the following graph, y equals 3x plus 4. Now, this is what I would do. I'd go, oh, hold on a moment. That's in gradient intercept form. So there's y equals mx plus c. So I know my gradient is 3 and my intercept is 4. Now, this intercept of 4 is my first coordinate value. I now know that I have a coordinate value at 0, 4. So I'm going to put a kiss on my graph. And you want to say a kiss. Don't go there too much about the way I teach maths. Now, the next one is the gradient, and I always say we need a gradient to be written in rise over run format, and whole numbers throw people completely. So I tend to write this as my gradient is 3 on 1, because I now know that my rise is 3 and my run is 1. So for every 1 across, I go 3 up. Now, having got my start coordinate, this intercept on my y-axis, then I'm done, because what I do is I go, okay, then 1, 2, 3 up and 1 across, put a kiss, 1, 2, 3 up and 1 across, do a kiss, 1, 2, 3 up and do a kiss. Now, I've done 4 there. Do I need to do 4? Generally speaking, I would do 3, but 4 is fine. And a word of warning, the number of people who then do this absolutely terrifies me. All right, so first things first, where I join that together, don't make it one continuous line. And I'm like, what are you doing? Please don't do that, right? This line goes on to infinity and beyond. By that I mean it absolutely has to go on. So you need to draw it to the edges of your axes. So as you can see there, I've drawn it literally to the box, and imagine this frame is drawn around these axes. I've drawn it and I've given the idea. So what I also do now is I'm going to put arrows on either side of that to say the graph continues. Now really that's saying I'm not limiting my domain, but we'll come back to that a little bit more. So that's one way of doing it. Here is another way of doing it. Exactly the same question. Sketch the following graph. Sorry, it's not the same question. It's a different question, but the same idea. But this time the question states you have to find the intercepts. So when a question states a method by which you've got to do it, then please, please, please do it that way. So what do we end up with? We have y equals 4x minus 3. So when it's finding the intercepts, it says, well, we know that the x-axis is the same as y equals 0, and we know the y-axis is the same as x equals 0. So what it wants me to do is say, well, if I've got the equation y equals 4x minus 3, firstly, put x equals 0. Well, that's nice because that goes, and that just gives me that y is equal to negative 3. So I have found my first intercept. Now you can turn around and say, well, hold on a moment, I could have just read that. That's in gradient intercept form. I know, there's lots of ways of doing maths. Chill, chill, chill. The next one, obviously, I'm going to make y equals 0. So in that situation, we'd end up with 0 is equal to 4x minus 3. Add 3 to both sides. Gives me 3 is equal to 4x, or x is equal to 3/4. So now I have another coordinate, 3/4 and 0. Again, the number of people who put 0 3/4 is terrifying. And I know why. It's because you've got y here is first. So you say, oh, there's 0 3/4. But it isn't. So I've got my 2 points, 0 comma minus 3. There's one. And I've got another one there as 3/4 and 0, which is here. And then lo and behold, is that 3/4? Nope, because there's 5 divisions there. So there's a half, there's roughly speaking 3/4, and so joining those together gives me my rather shonky line. But again, I've extended it all the way to the limits of my graph. The question stated to do that. Now, my apologies if you can hear background noise at this moment in time. That's not me breathing. It is an absolute thunderstorm which is happening here in Melbourne. And yes, very exciting. So please ignore it. The rain, I'm sure, will stop soon. I'm not sure about the thunder and lightning. So what about this one? Sketch a graph of 3x plus 4y equals 12. This is in intercept form. Love intercept form. Why? Well, funnily enough, we use exactly the same method as we did previously. So I have 3x plus 4y is equal to 12. So how do I find my intercepts? Well, I know to find my intercepts, I let x equal 0. And I let y equal 0. So if I make x equals 0, that disappears, which gives me 4y is equal to 12. So y becomes equal to 3, and so I have 0, 3 as one of my coordinates. And likewise, if I have 3x plus 4y equals 12, and I make y equals 0, that disappears. So 3x is 12, and x becomes equal to 4. So again, that's 4, 0, not 0, 4, 4, 0. Two coordinates, 0, 3, let's do a kiss. And 4, 0, let's do a kiss. Now, this is never going to join up. I promise you, I'm going to do my best. So now I'm going to try and draw this backwards. And hopefully, actually, not too bad in any way, shape, or form. Again, don't forget those arrows that says the graph is continuing. And again, do them to the limits of that graph. To be perfectly honest with you, there's nothing more exciting than that. It's the way it goes. Now we move on, and again in the previous video there was an opportunity for us to say, well, at times we need to find the angle between the x-axis and the line. So we need to find this angle here. How do we do that? Well, we know, again from the theory, that the gradient of a line is actually equal to that angle between the positive direction of the x-axis and a positive gradient. All right, so here is a very quick sketch. If there is my line and I know that my gradient is that, then that is theta, which is in the positive direction of the x-axis. So we're going to use that, but we'll come back to negatives in a moment. We'll come back to the negatives in just a moment. So find the magnitude of the angle theta that line makes with the positive direction of the x-axis for that function. Now great, first thing to do is I look at that function and I say, is the gradient positive or negative? Well, reading off from that, it's brilliant. My gradient is positive, so I can use that m is equal to tan theta. So what is the value of m? It's 3 is equal to tan theta. And so theta is equal to tan to the -1 of 3. How do I find that? Well, I don't know that off the top of my head, but I just so happen to have a wonderful, funky calculator. And there we go. So there's my calculator. Yes, it's the Casio ClassPad. If you don't have one of these, oh, you don't know what you're missing out on. I'm also a great lover of the TI Inspire, and videos will follow one day with the TI Inspire. But remember, little person doing a big job. So I'll add them as and when I can, but the general concept is the same. So for my Casio ClassPad, I do main, I hit my keyboard, and I go to my trig function there, which says I want to find the inverse tan, so find the button of inverse tan, and I put 3 in, and press enter. Now obviously in this situation it is critically important, and you can see from the red arrow now, that you have this in degrees mode. Okay, obviously if the question says radians, do it in radians, but for most of the questions you're going to do at the moment, it's degrees. And what does it come up with? 71.57. So 71.57 degrees is the angle that that line will make with a positive direction. The x-axis, easy peasy lemon squeezy. What about when it's written in this form? 3y equals 3x minus 6. Any difference? Well, the first thing I'm going to do is going to try and make sure that I have this. Sorry, fly in the studio. First thing I'm going to do is make sure I have this in gradient intercept form. So I've got 3y is equal to 3x minus 6. And in this situation, it was so simple. I'm just going to divide both sides by 3. So I can get y on its own, which gives me x minus 2. Now, it's a surprising number of people who look at that and go, there's no gradient. Yes, there is. Remember, we're trying to compare y equals mx plus c, and so the value of m is the thing in front of that x. So, looking at this, I know that my gradient is equal to 1. And do I need to know anything else? Well, no. Because my gradient is positive, I can use that m is equal to tan theta. Being such a consummate professional, you think I'd stop recording, but no, there are videos to create and there is time running by. So m equals tan theta. So 1 is equal to tan theta, or theta is equal to the inverse tan of 1. So how do we do this? Well, loading up our calculator, what do we see? Well, once again, I can go inverse tan of 1 if you would do me the honor, and out comes 45 degrees. Now, as it turns out, I already knew that was 45 degrees. Why? Because to have a gradient of 1, it is a diagonal line where there's 1 across and 1 up, and that's 45 degrees. And these type of things are really important to learn as you go through the course. It's used really quite a lot later on. And the last example for this lesson is taken from the Cambridge Essentials textbook series, which is freaking awesome. I use that textbook, and thank you, Cambridge, for giving me permission to use your questions. Greatly appreciated. So, find the magnitude of the angle that the line makes with a positive direction. Now, in this situation, I've got y is equal to minus 0.3x plus 1.5, and I now have a negative gradient. So my m is equal to minus 0.3. Now what that means is that in this situation with a line that's coming down here, this is the angle I'm trying to find here, that theta. Now, if I was to do m is equal to tan theta, and tan theta then is equal to minus 0.3, what we actually find out is this angle here. Now, actually, that's not the theta we want. That's actually alpha. So what I'm going to do is I'm actually going to say, well, tan of alpha is equal to minus 0.3. And again, it all gets really confusing because that minus just means that the angle is below the axes. Bringing up my calculator, if I type that in as tan to the minus 1 of minus 0.3 and press enter, it comes up as minus 16 point, let's say 7. So in this situation here, alpha is minus 16.7 degrees. Now all that means is that it's below that x-axis. I know that the physical size of that angle is 16.7, and through alternate angles, because we've got the z and we know the corners of the z are the same, this angle here is also alpha. How do I use that to find theta? Because that's the angle we want. Well, we know that if we take alpha away from 180 degrees, so theta is 180 minus alpha, so theta is 180 minus 16.7, which gives me 180 minus 16.7. Thank you very much. It gives me 163. gives me 163.3 degrees. Now again, you're probably shouting at there going, did you actually use a calculator for that? Yes, I did. Should I have done? Probably not. Okay, ladies and gentlemen, thank you so much for watching. This is the end of the lesson. What did we deal with? We dealt with graphing straight lines. I know, but we also did angles. It was very exciting. Once again, thank you so much for watching. If you can do me the honor, please, of subscribing, that would be good by clicking that button there. Otherwise, over there, yes, there is a video loading of much more math fun relating to the course this is related to. Thank you so much for watching. It's really good to see you. Have a good day. MaffsGuru out.